This is the Edexcel International A-levels. I'm doing January 2023 exam. This video is on question 6, which looks at modulus graphs. Just get this all set up. So this is modulus graphs, or graphs that kind of are only positive, so that you have the option to draw a straight line in the sort of with a negative gradient and a positive gradient. So if we take a look at this question, I have it already written out over here on the right. So if we just scroll through, for those of you who just want to look at the answers, so I first like to just scroll through it. So this is the question that we're working on, and this is answer for answer A, and then here I previously worked out for answer B. So you can just pause the video and take a look at that. Okay, but if there's anything you're confused about, I'm going to go through it in a little bit more detail. So the question gives this modulus graph equation, and it asks for us to answer a few questions. So let's take a look. So this one gives a little bit of information. Just want to look at the information first. The graph cuts the y-axis at point P. That's given, so that's just written on there. The Q and R are the x's, cuts the x-axis at Q and R, and point S has a minimum point at point S. Okay, so all of that is on the graph. None of this information over here needs to be added, so we can just move on to the question. So the question says, find in the simplest form in terms of A, the coordinates of these points. So first it wants point P, then Q and R, so, and then point S. So P, Q and R, and S. Okay, so that's what we're going for. So a little bit of explanation on this, this modulus graph. So if you have a modulus graph that is just y equals x minus a, then this graph will cut the x-axis. It can never, it's always positive. So neither the negative side of it nor the positive side of it will be, will go under the part that's underneath the x-axis of those straight lines. So if we take this as one straight line and this is another straight line, the part that's underneath gets cancelled out. So that's what this modulus does. It makes that there's two options, either plus or minus. So you would have maybe x minus a plus or minus. So this would, if we look at the one side of it, would be y equals x minus a. So I just took that plus in, and the other side of it would be y equals x minus x plus a. So when we times in the negative, then the signs change. Okay, so because of this, one of these is negative and one of these is positive. And if you sort of start to intuitively look at it, well, this one here has a negative gradient, so that's going to be your -1, and the other one, of course, has a positive gradient of 1, so that's going to be your +1. So your modulus graph gives you 2 lines, and that only the positive part is included. Having said that, this -2a has brought it down by -2 and times some sort of form of a. So that's why our modulus graph that we're working from can go under the x-axis, even though normally it wouldn't. Okay, so it's been shifted down outside the modulus. So this is what we're working with. And in order to find these questions, the first thing I like to do is just to sort of figure out which is my negative and which is my positive. I mean, if I look at this, you can kind of already see that this one is a line slanted to the left. That means it's negative. And the other side is a slanted line to the right. That means it's a positive gradient. So we know that the purple one is going to be the negative gradient and the blue one is going to be the positive gradient. But the first thing, what I really want to do is I want to work out those 2 equations. So I'm just going to split my page like this, say y equals -3x or -3x plus 5a minus 2a. And then on the other side, I'll have y equals, no, this is a negative or a positive inside the modulus sign. So we have 3a minus 5a. So this is just taking the positive one minus 2a. Okay, so I've times them both out. So we started off with working from this and assuming that it could be negative or positive. Okay, and then after that, we have to minus the 2a. If we simplify these, we get y equals minus 3x plus 5 minus 2a is plus 3a's. And then on the other side, we get y equals 3a minus 7. Excuse me, this was an x. Okay. 3x minus 7a's. So these are 2 graphs that we're working on. You can see them already written out on the right over there. And if we take a look at those 2 equations, we only need to look at the negative one. So we're looking at, on this side is the negative gradient. And that for working out P, that's the only one we're going to be using. But I just want to write them in. So we have y equals 3x minus 7a. Okay, so first step, match up the correct gradient to the correct line. And then you can see sort of P and Q are on the pink one, which is the negative gradient, and R is on the blue one, which is the positive gradient. So all the questions after you've done this step, everything becomes a little bit easier. From there, we know that it's the y-intercept. So just gonna pick a bit. For y-intercepts, just let x equal to 0. This is number 1. Excuse me, number 6a. And we can just sub x is 0, so minus 3, 0 plus 3a. Okay, and obviously then we know that the y will be 3a when x is 0. So that means our point P is 0, 3a. This is a nice solid method. Another way you could do it is just by inspection. You know that if you look at y equals mx plus c, which is the standard form of a straight line, then we know that c represents the y part of the y-intercept. So that's c directly, as long as we've got our equation written in standard form, we can already see that what C will be, it'll just be 3A. Right, part AII asked for Q and R. So the next thing we do, which are the x-intercepts of each line. The x-intercepts of each line. So once you've got the y-intercept, we had to let x equal 0. So in order to get the x-intercept, you can do the same. You just let y equal to 0. So one pretty solid method is on each line, we can let y equal to 0. So for our x-intercepts, okay, let y equal 0. Okay, because y is 0 on this line. Y is always 0. Okay. So first we can do the negative one, 0, where the y was. And this is our negative gradient. 3a, just a little bit of algebra, take it over the line, and then divide both sides by 3. So, oh, I went the wrong way. I don't want a on its own, I want x on its own. There we go. So x equals to a. So I did the negative one first, which means we did q. Okay. So for q, our x is equal to a. So our y was 0, so it'll be a 0. And for r, we have the positive gradients. So we have y equals to 3x minus 7a. And just take the 7a over. We want x on its own, so divide both sides by 3. And that side cancels out, so it's 7a. So x is equal to 7 over 3a, which we can just write in here. And 0. Okay. Number I wants for point S. So just still, did I do S on the side? A. Okay. So point S is the point of intersection between the two lines. So obviously one method that one can always use for points of intersection is you let the y equal y, and that's then the right-hand side will equal the right-hand side of each line. So just using color, that means that the point S is where those two lines meet. So we can just take those equations and equate them to each other. That's one way of doing it. So just quickly show you how that works out. Just want to find my working on the right here. So if you wanted to look ahead. There it is. Okay. Let's take a look. So we have two lines meeting at this point. So at that line, the equation for the blue line and the equation for the purple line will both be true. So we can say 3x plus a at point P, oh, excuse me, not PS, at point S will be equal to 3x minus 7a. Okay. A little bit of rearranging. Just always remember what you're trying to get. We're trying to get x on its own. So I always try and make the x positive. So I'll bring both x's to the right. That'll be 6x, so plus minus 3x, plus 3x on both sides. And then we have bring the a's to the left. That's plus 7. That's going to be 10 a's. Divide both sides by 6. And that cancels out. And you have x is equal to 10a over 6, which is 5a over 3 simplified, or 5 over 3a. Okay. So that's our x, but we still don't know our y. So the next step is you sub it into one of these equations. So you can either sub it into this one or this one. It'll both be true. I'm going to choose the positive one because it seems a little bit easier. So I write this in my proof. I say sub x equals 5/3a into 3x minus 7a. And then therefore you just, wherever you see an x, you put this instead. So 3 times 5/3a minus 7a. Just a matter of doing a little bit of algebra to finish that off. So these 3's cancel out. Let's be 5a minus 7a, and then you get negative 2a as your y. So what we've said, we've used the algebra to prove that when x is this, y will be this. Okay. So our point, I think it was point S, is going to be 5/3a minus 2a. And that's the answer to 6a III. So let's just get that in there. 5/3a minus 2a. Okay. Next we have 6b. So just get the question up for you. So 6b just says find in simplest form in terms of a. And now they've added something to the equation. So they've added this part. So if we look closely at this side on the left is just our graph that we were working with. That's our modulus graph. And now they want to know what x's will we get when it's equal to another modulus graph on the other side. So let's take a look at this. So we have this equal to x minus 2a, and find in this form in terms of a. So when they say in terms of a, they mean they want x on one side equal to something with a's in on the other side. So this is in terms of a. Okay. So this is just something we need to simplify. So it's just something we need to know how to simplify it. So for those of you who want to look ahead, done the answer already over there. Okay. There's a few ways to look at this. I can see I looked at it using a sort of gradient method. So let's take a look at our new graph first. We have a new modulus to unpack. So if I were to unpack this new modulus, it's going to be x minus 2a plus or minus. So we have a positive and a negative again. So let's take a look at that. So it'll be, if we do the positive gradient first, it'll be x minus 2a. So that's the positive gradient. And if we do the negative gradient, that will be minus x plus 2a. So these are our new lines written on the graph. And when I look at these, I immediately think to myself that the gradients are negative and positive 1. So if our gradient is negative and positive 1, it has a less steep slope. So if you look at our original graphs, these had a gradient of negative and positive 3. So the slope of these new graphs are less steep than the ones before. Another thing, if we look at these two lines, is they haven't been shifted up or down. So the previous one here had a shifting up and down. This one doesn't. So that's another thing I noticed immediately. So we have new lines that are going to follow the rules of modulus graphs, is that they can only be positive. So they're going to go like this. Okay. they're going to go like this, and the gradient here is going to be -1. The -1 slopes to the left, and the gradient here is going to be +1 because the +1 slopes to the right. So if I draw those in alongside the other ones that I have here, what was the, so 2a, we don't know what, I'm hesitant to draw it in yet. Let's examine that 2a first, because we don't know what that 2a, because of this unknown a, we don't know, sort of where this point is on the graph. Okay, so before I sketch it into my sketch alongside the other ones, I first want to show you what happens with that 2a. Well, let's see. So I'm looking at the Q and R, and I see that this one is A, and this is 7/3a. 7/3a is more than 2a, because 7/3, if you draw it as a mixed number, would be, oh gosh, 2 and 1/3a's. Okay, so what I notice is if x is 2a, it's going to be between Q and R somewhere. We don't know where. Most likely where I've drawn it isn't great, because it's probably closer to this one, closer to the right. Let me make it red. So I would say it's going to be kind of there. So obviously, because this is 2 1/3 a, so it's a third less than this. Okay, so let's look at that. So we have it from there. It has a less steep gradient. So if I were to draw in lines, I kind of be imagining, well, the gradient's a little bit less steep. It's going to look like that and like that. And so the points of intersection that they've asked us for, which is what they've asked us for by putting an equal sign, is going to be there and there. So those are the points of intersection, and that's what we're looking for. So why did I do all of this? I find sketching is kind of helpful with modulus graphs, because there's a lot of margin for error. Students kind of like choose the wrong line for the wrong thing. So what I've achieved is I now know that if, let's call this, what have we used, A, B, C, let's call this point A, and let's call this point B. So our point A is on the negative side. Now, of course, intuitively, you could have said, well, the -1 is going to be there, but this is the full explanation is just to make sure, because sometimes it doesn't work out that way. So, okay, so we know that the two graphs that we're equating to get the x of point A is going to be the two negative graphs. So that's already a big step. So we can move straight into, we already had our negative and positive graphs of this. So I'm going to just do the -1. So the negative was y equals -3x plus a. Excuse me, 3a. And the -1 of the new modulus graph that we're looking at is y equals -x plus 2a. Just checking on the right here, because when I teach, so we're doing this over here. Okay, so just a little bit of algebra to finish it up. If y equals y, then the right-hand side has to equal the right-hand side. Okay, so for the purpose of this teaching video, I'm just going to erase. I'm just going to erase this. So this is what we end up with. I'm looking at my x's. I always remember I want x on its own because they asked for x. So I will arrange, I always try and arrange my x's positively. So take the 3x, the -3x to the other side, and -x plus 3x is going to be 2x. Take the a's to the left. Be 3a minus 2a is just going to be a. Divide both sides by 2, and you end up with x equals 1/2 a. Okay, so that's one of them. Now we can do the other side. So this was the point which I called point A on the picture. And now we do point B. So point B, we're looking at the two positive graphs. So our original graph was 3a minus 7a, and we're equating this to x minus 2a. So the two positive gradient straight line graphs. Okay. So again, oh, nope, something's wrong with that. I think this is supposed to be an x. Oopsie. That's better. I want to get all the x's to one side, so I always choose the positive x side. So yeah, this is just the way I like to do it. You can do it however you at this stage in P3 algebra. 2x equals to 5a. Divide both sides by 2, and we get 5 over 2a. So we have two values of x, and I think that's as far as this question is asked for. If the question had asked for the actual point, obviously you'd need to get the y as well. I'm just rechecking the question. It only asks for the values of x. Okay, so then we're done. Those are our values of x. And that was question 6. Good.